Hello everyone. So today we will learn how to name bicyclic and Spiro compounds in a very easy way using RPSC nomenclature. So before learning nomenclature, first let us understand the basic difference between Spiro and bicyclo compounds. So in Spiro compound, two rings, like here you can see two rings are connected through only one common carbon atom. So this common carbon is called the spiro atom. So both rings meet at a single point. But in bicyclo compound, the two rings are connected through two bridgehead carbons. So here you can see these two carbons are the bridgehead carbons. So these bridgehead carbons are connected by different bridges between them. So the main difference is the spiro compounds have one shared carbon atom and bicyclo compounds have two bridgehead carbons. Now let us learn stepwise nomenclature of spiro compounds. Using this example, spiro 3,4 octane. So first identify the common carbon joining both rings. So here two rings are there. So this carbon is the spiro atom. So this carbon is called the spiro atom. Next, now count the carbon atom in each ring, excluding this spiro atom. So for this ring, here 1, 2, and 3. Three carbons are there. And for this ring, 1, 2, 3, 4. Four carbons are there. So here always write the smaller number first. So here in first ring, this one is the smallest. So here is the three carbons, and in second is four carbons. So three and four carbons. So we write like this 3 and 4. Next, now count total carbon including this spiro atom. So here is three carbon is here, four carbon is here for this bigger one, and one is a spiro. So total carbon is 8. So here total 8 carbons are there. So for 8 carbon we use root word for 8 carbons, octane. So finally write the complete name in the format like this. First spiro, then x is the smaller number for the ring and y is the longer one. Then bigger one means then alkane, alkane. So finally for this compound here we can write spiro 3,4 octane. So first for the smaller one, then larger one. So first we have to find out the spiro atom, then count carbons in both rings excluding this spiro atom, then count total carbons, then write the final name. So now let us solve this nomenclature question step by step. So first here observe the structure carefully. So here is the two rings are connected through one common carbon atom. So this is a spiro compound. So first we have to check this one is a spiro or bicyclo. So this one is the spiro compound. So now count the carbons in both rings. So this one is the small rings contains here two carbons. So after excluding the spiro, here is a three carbons. So after excluding the spiro carbon, it becomes two carbons. Next one is the five carbon. So after excluding the spiro carbon, here is a four carbons. So therefore, parent name becomes spiro 2, 4. So total carbon here is seven. So for seven, root word is a heptane. Hep So Spiro 2,4 heptane, this one. So now we do numbering to give lowest position because here is a two here is a two ketone group are there. So now we do the numbering to give lowest position to the ketone groups. So after this Spiro atom, we start the numbering. So here is a 1, 2, 3, 4. So this one is a 4 number carbon and for this carbonyl group is a 7 number. So since there are two ketone groups, so we use the suffix dione. So the final name is a spiro 2,4 heptane 4,7 dione. So correct answer is the Spiro 2,4 heptane 4,7 dione C. Now let us learn how to name bridgehead, bridged or bicyclo compounds step by step. So here our example is bicyclo 2,2,1 heptane. So step 1 is the first identify the two common carbon atoms shared by both rings. So these are called the bridgehead carbons. Now count the carbon atoms present between the bridgehead carbon through each bridge. So in the first bridge, so here you can see here is this one is the first bridge. So here these are the two carbons are there are also there are two carbons. In the second bridge there are also two carbons, one number and two number. Next is this one, this bridge. So here in the third bridge there is only one carbon. So and here we do not count the bridge head carbons. So now write these numbers from largest to smallest. So for the Spiro we are write like a smallest to largest. For bicyclo we have to write from largest to smallest. So we write 2, 2 and 1. So first bridge is the 2, second bridge is the 2 and the third bridge is 1. So here these numbers showing the how numbers are there in the ring. So now count total carbons. So total carbon is a 2, 2, 1 and these two bridge head carbons. So total is a 7 carbons. So root word for 7 is a heptane. So finally write the name in the format of this. Large this XYZ is a we have to write like largest to the smallest number. So bicyclo first, then 2 to 1 and then heptane. So during the writing the name of the bicyclo compounds, we have to check first, find the bridgehead carbons, count the carbon in all bridge, then write numbers in descending order, then count total carbons, then write the final name. So now let us solve another example in a easy way. So first count the total carbon atoms. So here these two carbons are connected for these two rings. So first count the total carbon atoms. So total carbon atoms are 4. So for 4 we have root word we used here butane. We have to use butane. Now identify the bridge head carbon, then count carbons in each bridge. So first bridge contains one carbon, second bridge also contains one carbon, third bridge contains 0 carbon. So because there is a direct because here direct bond between the bridge head carbon, so we have to write 0 for this bridge. So the bridge notation becomes 110. Now write the final name using the format bicyclo-XYZ alkane. So therefore name is a bicyclo 110 butane. Now let us understand another bicyclo compound example step by step. So here first count the total carbon. So here is the total carbon. So total carbon is 8. Total carbon atoms are 8. So the parent name becomes 10. Next, now count the carbon present in each bridge between the bridge head. So here for this bridge, 2 carbons. For this bridge also 2 carbon. And for this bridge also 2 carbons. So in the first bridge there are 2 carbon, in the second bridge there are 2 carbon, and in third bridge there are again 2 carbons. So the bridge notation becomes 2, 2, 2. Now write the name in the format bicyclo XYZ alkane. So therefore the final IPSC name is the bicyclo 2,2-octane. So here always remember in bicyclo compounds bridge numbers are written from largest to smallest. Now let us solve this heterocyclic Spiro compound example. So first observe the structure carefully. So here is the two rings are connected through the one common carbon atom. So this is a Spiro compound. Now count the ring atoms excluding this Spiro carbon. So here we have to write from smaller to larger. So first numbering start from this smaller ring. So smaller ring contains 4 atoms, and this larger ring contains 5 atoms. So the Spiro notation becomes Spiro 4 5. Okay, so now count the total atoms. So here total atoms, 4 for this smaller ring and 5 for the larger ring, and 1 is the Spiro. So total 10 atoms. For 10 atoms, parent name becomes decane. So oxygen is represented by oxa and nitrogen represented by aza. So now numbering start from this smaller ring and near the heteroatom to get the lowest numbering. So after numbering, oxygen becomes, we have to start from here, 1, 2, 3, 4. Then 5, 6, 7, 8, and this one is the 9. So the final IPSC name becomes 9 oxa, 6 aza, Spiro, 4, 5 decane. So therefore correct answer is option B.